Imagine waking up and the modern world is gone. No lights, no phones, no banking. Air traffic frozen mid-route. Now here's the twist. This almost happened. Not in some distant future, but in 1989. And hardly anyone remembers. A storm, not of clouds, but of charged particles, slammed into Earth and quietly exposed a terrifying truth. Our entire civilization is built on a system the sun can tear apart in minutes. So what really happened the day a superpower vanished from the sky? On March 13th, 1989, millions of people in Quebec were plunged into darkness in less than a minute. Power plants failed. Transformers groaned and blew. Control rooms lit up with alarms, then went dark. For 9 long hours, a chunk of the developed world simply disappeared from the electrical map. Most thought it was just a blackout. But it wasn't. It was a warning shot from 150 million kilometers away. And it raised a disturbing question. If this was only a glancing blow, what would a direct hit look like? To understand that night, we have to start 3 days earlier, on the Sun. In March 1989, solar cycle 22 was raging. Sunspot group 5395, one of the largest of the cycle, twisted with magnetic tension. On March 9th and 10, it unleashed powerful X-class solar flares. But the real danger wasn't the flash, it was what followed. A coronal mass ejection, a colossal cloud of magnetized plasma, blasted off the Sun's surface, headed straight for Earth. And there was no way to stop it, only to endure it. When that CME reached Earth in the early hours of March 13th, it didn't just hit us, it collided with our magnetic shield. Earth's magnetosphere buckled and rang like a bell. Geomagnetic storm indices shot off the charts, reaching what scientists classify as a severe storm. Auroras surged far beyond their usual Arctic home, but that wasn't the only problem. As the magnetic field fluctuated wildly, it induced electric currents in anything long and conductive on the ground, especially the vast power grids that knit modern society together. Quebec was particularly vulnerable. Its grid relied heavily on long, high-voltage transmission lines built over resistive Canadian shield rock, a perfect setup for geomagnetically induced currents. Around 2:44 a.m. local time, those invisible currents surged through Hydro-Quebec's network. Protective relays tripped. Lines went down in cascading failures. In just 92 seconds, the entire provincial grid collapsed. 6 million people were suddenly without power. No heating in sub-zero weather, no lights in hospitals, no functioning subway in Montreal. And remember, this wasn't sabotage. It was space weather. On the ground, confusion spread faster than information. Montreal's metro ground to a halt. Offices and factories shuttered. Radio stations scrambled to stay on backup power. In some places, water pumps faltered. Residents lit candles, wrapped themselves in blankets, and waited for answers that weren't coming quickly. Hydro-Quebec engineers raced to restart the grid, but repeated attempts failed as long lines and stressed equipment resisted synchronization. Meanwhile, strange reports trickled in from beyond Quebec's borders. This was not an isolated incident. The storm's fingerprints were global. Across North America and beyond, the storm probed other weak points. In New Jersey, at the Salem nuclear power plant, a $12 million generator step-up transformer suffered severe damage from geomagnetically induced currents. In the United States, hundreds of anomalies were recorded in power systems. Satellites in orbit experienced glitches and sensor upsets. Some temporarily lost control. In space, the storm distorted radio signals and disrupted high-frequency communications. But it was what happened in the sky, visible to ordinary people, that made this invisible assault from the sun impossible to ignore. Auroras spilled far south of their usual haunts. That night, curtains of red and green light were reported over Texas and Florida, and as far south as Cuba. Airline pilots saw shimmering sheets of light from their cockpits. Some people thought it was a strange kind of dawn. Others feared it was a sign of something catastrophic. They weren't entirely wrong, because while the lights danced overhead, military and intelligence agencies quietly realized a chilling reality. Their high-tech machines were at the mercy of this cosmic storm too. Space weather in the late Cold War wasn't just an engineering problem, it was a strategic one. Earlier storms had already caused concern. In 1967, a major solar storm disrupted NORAD's early warning radars, almost being mistaken for Soviet jamming. By 1989, the US and Canada knew solar storms could mimic or mask hostile actions. That night, as systems flickered and sensors misbehaved, defense analysts had to distinguish natural interference from possible attack. The sun, unintentionally, had the power to confuse the world's most advanced militaries, without firing a shot. If 1989 was a warning, history held an even scarier precedent, the 1859 Carrington event. On September 1st that year, British astronomer Richard Carrington watched an intense solar flare. Hours later, telegraph systems worldwide went haywire. Lines sparked, paper caught fire, operators received shocks. Auroras appeared as far south as the Caribbean. And that was in a world without power grids, satellites, or global internet. Modern scientists estimate that a Carrington-level storm today could cause damages in the trillions and take years to fully recover from. 1989 hinted what that might mean. Our world is far more fragile than in 1859 or even 1989. Now, GPS guides ships, planes, financial trades. Satellites carry phone calls and internet traffic. High-voltage supergrids move power across continents. A strong geomagnetic storm can distort GPS, disrupt communications, drive damaging currents into transformers, and confuse satellites' electronics. In 2012, a Carrington-class CME narrowly missed Earth by about a week. NASA called it a near miss. The 1989 Quebec storm, in hindsight, wasn't an isolated disaster. It was an early chapter in an ongoing vulnerability story. After 1989, governments and scientists took space weather more seriously. Agencies like NOAA's Space Weather Prediction Center and NASA expanded monitoring of the sun with satellites such as SOHO and later SDO. Power operators developed geomagnetic disturbance procedures, rerouting power, reducing loads, and watching transformer health during storms. The North American Electric Reliability Corporation began crafting standards to harden grids. But that wasn't the only change. The storm also pushed space weather from a niche scientific curiosity into a recognized national security and economic risk. Yet, even with these reforms, the weakest link remains troubling. Large power transformers, the backbone of modern grids, are expensive, custom-built, and slow to replace, often taking months or more. A severe storm could damage many at once. Studies by the US National Academy of Sciences and other bodies have warned that prolonged, widespread blackouts could disrupt water, food supply chains, finance, healthcare, and more. Some experts argue we still underestimate this risk. Others say we're slowly catching up. But everyone agrees, ignoring 1989's lessons would be dangerous. So, why is the 1989 Quebec blackout so often forgotten? Partly because power returned in hours, not weeks. Civilization didn't collapse. People went back to work. The headlines faded. But beneath that apparent normality, the storm had already changed how scientists, governments, and utilities viewed the sun. It proved a superpower's infrastructure could be knocked out, not by enemies, but by physics. And it left us wrestling with a sobering thought. Our greatest vulnerability may come from the very star that makes life possible. Today, every sunrise is also a roll of the cosmic dice. Severe solar storms are rare, but not mythical. The 1859 Carrington event and 1989 Quebec blackout are proof. Another major storm will come. It's a matter of when, not if. Our challenge is deciding how prepared we want to be before that day arrives. The forgotten solar storm of 1989 quietly revealed how thin the line is between normal life and sudden darkness. If you enjoyed this deep dive into the unknown, subscribe for more uninteresting history.